no topology is complete if we don't have a routing protocol to run on top of it. I mean, that's the golden rule of the routing and switching CCIE exam. So what we want to do is we've explored what happened in phase 2 with regard to EIGRP and OSPF. Let's take a look at what happens with EIGRP in the context of a phase 2 DMVPN. I'm sorry, we explored phase 1. Let's look at phase 2. So let's cut over. Whoop, sorry about that. Let's cut over to the topology and make this happen. So we have phase 2, and all I really want to do is enable my routing protocol. We're going to run the tunnel interface in EIGRP 100 again, and we're also going to advertise our loopbacks. Let's make that happen real quick so that we can explore what's going on. So let's see, R2, config T, interface, no, router OSPF 1, or EIGRP I said, sorry. EIGRP 100, no auto, network 2.2.2.2, match it exactly. Network 10.10.10.2, match it exactly. Do show IP EIGRP interface. And we see we're running 100, loopback and tunnel. So we're good to go there. So let's cut over to R4, do the marrying config. Router EIGRP 100, network 4.4.4.4, matched exactly. And network 10.10.10.4, match it exactly, and no auto just for my sanity. All right, go to R5. Router OSPF 1, sorry, EIGRP 100, no auto, network 5.5.5.5, match exact, and network 10.10.10.5, match exact. And then lastly, 6. The loopback and the tunnel. All right, let's go to the hub and see if we've got all of our neighbors. Show IP EIGRP neighbors. We have 6, 5, and 4, and we have queue counts of 0, and we should have everything in our routing table. Show IP route, EIGRP, and we have all the interfaces that we would expect. Let me specifically restrict this to 100, so we see the 3 loopbacks. So everything's hunky-dory and fine in our world right now. Well, is it? Now, just like phase 1, phase 2's got some issues for us. We've got the ability to resolve spoke-to-spoke reachability, but do we have a problem with the idea of split horizon? And the answer to that question is most definitely yes. So what we want to do is, even in phase 2, we need to make certain that we go into the interface and we turn off that behavior. So let's take a look at what's happening. So on R2, let's illustrate what's happening. So on R4, show IP route EIGRP 100. Notice I only see 2. I don't see 5, 6, or, well, I'm not going to see 4 because I'm 4. So let's go back up to the hub. Interface, tunnel 0. No. IP, split horizon, EIGRP 100, enter. Now let's go back over to 5. Notice graceful restart because we synchronized. Guess what? We're going to have routing information in here. Show IP route, EIGRP 100. Ta-da! We have reachability now. So ping 200 or 2.2.2.2. Ping 4.4.4 and ping 6.6.6. Trace route 6.6.6. Now hold it. Whoa, something freaky's going on here. 30 seconds ago, we didn't have a routing protocol. Now we got a routing protocol. We're running EIGRP, and notice the sucker's traversing the hub for every individual ping that we send, or trace route. I mean, we could go through here and do this one more time, 5 to 6, straight to the hub. But that boggles my mind. Show DMVPN. Well, we've got dynamically learned prefixes to reach our spokes. Why in the world would we be navigating the hub? Let's take a look at our routing table. Show IP route, And I want to look at 4.4.4. Well, let's see. Let's make sure we're doing the same one we were doing. So I was pinging 6.6.6. Of course, I picked the wrong IP address. 6.6.6. Look here. I learned it from 10, 10, 10, 2. The next hop is 10, 10, 10, 2. So I'm sending all of my information to the hub. But, I mean, think about it. I mean, it'll give you a migraine when you first start looking at it. I'm in a phase 2 DMVPN. Why in the heck would I be sending my traffic to the hub? Well, again, it falls down to understanding exactly what happens with our IGPs, our routing protocols. EIGRP is going to do next hop self as it advertises information that it learns across the hub. So to reach 6.6.6, I need to go to 2. To reach 4.4.4, I need to go to 2. To reach 2.2.2, I need to go to 2. So all of my traffic, based on my routing, is going to traverse my hub. Why? Because the hub is going to be the next hop device. Let's modify that behavior. How do we do that? Well, we go to the hub. Let me grab the right thing here. Let's go to the hub. No. Didn't mean to yell at you. No IP. No EIGRP. I always hate this. Router OSPF or EIGRP 10. 100. No EIGRP. It's under the interface. Can't remember the stinking command, guys. Sorry, just bear with me 1 second. I hate it when I draw blanks. That's the cool part about not having to do this kind of thing in the regular configuration. So, it should be no IP next hop self, but I thought I tried that. Interface, tunnel, 0. No IP. Oh, next hop self. I hate EIGRP commands. They drive me bug nuts. And what we're going to do here is we're going to say no IP, next hop self, EIGRP 100. And what we're going to do is we're going to plug enter. So do show run interface tunnel 0. Notice here my next hop self value changed, so that's going to give me new adjacencies. Now this is what I lovingly refer to as an RPE in a live environment, a resume producing event. If you don't know what your system is going to do when you make a change in a configuration, make certain that you do it during an engineering change window. All right? I can't tell you how many times students say, well, you did a show debug and looked at every packet, and the next thing I did that on my work environment and the entire environment collapsed. Well, that's what we want to avoid. So I'm always going to try to point out resume producing events. All right, RPEs, as I lovingly refer to them. So now let's look at what happens on our spokes. So let's cut that back down to, actually no, I want to look at the tunnel, because what I want you to see here is for a layer 2 VPN, or phase 2 VPN, excuse me, those are the two configuration commands that we need for EIGRP to allow the underlying DMVPN to do its job. Because now what we're going to find is when we go to one of our spokes, we're going to find out that our next hop modification has not changed. So it's going to be the originating device, not the device that we quote unquote learned it through. Remember, our peerings are with our hub. So let's take a look at this. So let's cut down to one of these guys. Show IP route. Tunnel 0. Show IP route for 6.6.6. Now notice we learned it from 2, but the next hop IP address that we're going to use is 6.6.6. So now we're going to have all of the information necessary such that our layer 2 environment, which is quote unquote DMVPN at this point, is going to be able to work in unison with our IPv4 routing table in order to allow our traffic to take the path that we want it to. Remember, routing is going to be what determines how our paths go. The layer 2 infrastructure, or in this instance the DMVPN, is merely identifying the avenues that we can use to reach destinations. So keeping in mind, by not changing the next hop information, by telling it don't change it, stop the next hop self configuration, what we're going to do is we're going to bypass the hub. So let's see if that actually works or if I'm full of hot air. All right, so right now what we'll do is we'll configure it. So right now, if I trace route to 6.6.6, Notice I went directly to 6. So let's see if I can go to another one. Let's say 5 to 4. So trace route, .4.4.4, straight to 4. So let's take a look at our tables. Show DMVPN, and we see our dynamically learned tables. All right? So you just saw what Phase 2 DMVPN does to an EIGRP deployment. And the outcome is going to be the same irregardless of whether we're running classical mode EIGRP or whether we're running the idea of multiple address families or named EIGRP operation. So with that said, that wraps this video. I'll see you guys in the Phase 2 OSPF demo that's coming up in the next video. Bye-bye.